Today I'm headed to a top secret wildlife sanctuary where Colossal Biosciences is working on bringing back the bluebuck, an antelope that went extinct in the late 1700s. I'm going to have the chance to get hands-on with the research team to show you guys exactly how they're going to be bringing this animal back to life. All right, we're headed over to the blind to drop Ray off so that he can get an aerial perspective of the first darting attempt. Wow, they are so much bigger once you see them in person. Target set. Let's go, man. Yeah, good hit. Perfect shot. Now, Matt, how long will it take for the animal to settle down and us be able to approach it?
Yeah, with the cocktail we gave her, it's about a 10-minute induction period. So that means for the next 10 minutes, the drugs are slowly going to take effect.
Yeah.
It's in a big fat muscle, so it takes some time for the drugs to dissipate through the muscle. But also, as you see, and once you fire a dart, they get a little excited.
Yeah.
They can override the drug sometimes too. So we have to give them space, let them chill out.
All right. And up, falling asleep.
That's a nice steady induction, right? She's not falling over, she's not flailing.
Yep.
She looks happy, healthy.
Calmly sitting down, kind of looking at the dart, like, you're getting tired. And you might be wondering, Coyote, what animal is this and why did it just get darted? This is a Roan antelope, a species native to sub-Saharan Africa and a close relative of the bluebuck. Tranquilizing her is just the first step. So while we wait for the serum to take effect, let's meet up with Dr. Pask and discuss why Colossal has chosen the bluebuck as their next de-extinction target. Right now we're sitting at Colossal in the dire wolf den conference room, and I love this because it's the unique opportunity to tie the revolutionary work that Colossal did with the dire wolf specifically to now what you guys are doing with the bluebuck, your second mammalian species that will be brought back from de-extinction. But how is this much more complex than working with canids?
Yeah, so starting off with the dire wolf, we already knew a lot going into that project. We understand a lot about dog reproduction. We've been able to do things like egg collection from dogs, embryo transfers in dogs. All of that was already known. So that gave us a great head start on the dire wolf project. But then moving now to do bluebuck and moving into antelopes, these are a species that we really knew nothing about. Nobody had done oocyte retrieval before, people haven't done embryo transfers, and that whole group really lacks a lot of those core technologies that we need for conservation as well as for de-extinction science. So in this particular project, we've had to develop all of those things from the ground up.
Why is it so important that we are bringing back the bluebuck?
So the bluebuck was the first large mammal species to be a human-driven extinction event in Africa. So it's this really important animal to bring back, not just for that, but there are 29 other species of antelope closely related to the bluebuck that are also critically endangered. And so the technology we're going to learn from this project will help to bring those other species back from the brink of extinction, and they all play critically important roles in maintaining a healthy ecosystem and landscape. So being able to not just bring back the bluebuck, but help save these other species will help ensure that we have a really healthy ecosystem for many more years to come.
Well, it looks like our female is just about asleep, so I think we're going to get ready to move in. It's going to be pretty cool to see what it takes to actually extract the oocytes from the back end of this antelope.
So we'll drive her over to the procedure room. That's where the vet and Parker are waiting so that we can start this procedure.
Wow. All right, I'm in head support right now. I got to watch out for the horns.
Awesome, we'll see you in there.
It's drooling on me.
Yeah, it's a good sign.
Okay, now we're gonna do the ovum pickup.
First, we're gonna check her out, make sure she's doing okay. We're gonna get a temperature.
Okay.
And we're gonna look at her ovaries to see what is on them.
Okay.
And then we're gonna extract any of the oocytes that we can.
Whoa, what's that glove that you just put on?
Oh, this is to protect my arm for what we're about to do. So I'm gonna clean out her rectum. So remove all of the poop.
Oh, yep, you just went, oh wow, look at that.
And then clean her up before the procedure, because fecal matter is the dirtiest part of this, and so we want to get as much of it out of the way as possible. This is good looking poop.
Okay,
Yeah.
what is bad looking poop?
When it all sort of sticks together and really smells bad.
Okay, it actually does not smell like anything if anybody's wondering.
Right, so the next step here is to just do a reproductive exam. So this is an ultrasound probe So like this big dark space is a bladder.
Okay.
And then if I go a little bit forward, the reproductive tract should sit right on top of or beyond it. So this right here is like a loop of uterus. And I follow that to find an ovary, which is that thing right there.
Oh yeah.
Sitting right on top of the bladder.
Okay.
So then these big black circles, those are all follicles. So we want to see how many she's got and how big they are.
And the follicle is your target, correct?
Follicle is our target. So she has a 0.7. A 0.7 is 0.7 centimeters, so 7 millimeters. And the needle we'll be using is a 20 gauge needle. So sometimes the follicle is about as big as the needle.
You said needle? We're going to put a needle in
We're
there?
gonna put a needle in here.
Oh, wow. Is that
that's-
how you extract the oocytes?
That's how we get the oocytes out, is we have to put a needle into the follicle to actually.
Okay, so did this investigation show you that there are some oocytes that we can actually remove from this antelope?
Yes.
Interesting.
So now we're gonna get her ready to go extract the oocytes.
Okay, you're being so good.
About to introduce a needle, and so we want to make sure everything's as clean as possible.
Ta-da!
Ta-da! And now the most important part is to not let the tail drop, because this is
Got
our
it.
clean field, so
Yep.
now we want to keep it clean.
Okay, so Parker, what is this device that you've got?
So this is we call it our ovum pickup device. And this was adapted and basically custom made for us at Colossal. These white pieces were 3D printed for us to house this needle guide and then the actual needle driver that we're gonna use.
Wow.
So we introduce that into her vagina, and then I go back into her butt and will try to hold her ovary so that we can get a needle into it. So you can see on the screen there, I have the ovary now. That dotted line going down the screen is my needle guide. So what I want to do is line up the dark circles so that they're in the path of my needle. And then once the needle is in that circle, it should collapse and we should hopefully recover an oocyte. So I'm just trying to make sure that I'm gonna hold it steady. And there's one. You saw it collapse?
Yeah. Ooh, I think you got another one.
So I got two there.
So an oocyte is essentially an egg, same thing.
Yes.
Okay. And now not every follicle is guaranteed to have an oocyte in it, correct?
It should, but we're not guaranteed to recover it.
Okay.
There's one.
Ooh, good get.
So now we just flush the line to make sure that anything that might be left in the needle or the line gets moved down into our tube.
Whoa, is that the good stuff?
That is hopefully all the good stuff. And now Daria's gonna go look for them.
Tail going down. And now I go with Daria to see whether or not Parker has successfully Pac-Man'd up those oocytes. Okay, so we are now into the secret room where Daria is going to extract the oocytes and make sure that we actually got them out of the follicle.
Exactly. So these special dishes have a grid to help me look. These guys are microscopic, so hopefully we have a decent number in here. The goal is to get as many oocytes as we can. So you can see there are a ton of things in this dish. There's other cells that we will find. And so I'm gonna take my time and look through this and try and find a couple oocytes, because Parker was able to aspirate out different follicles.
I see how the grid definitely helps. So you're at 1A.
So in 1A, I'm gonna go down. I'm gonna adjust my lighting so it's nice and bright. So I already see one.
Oh, you do? Is it that?
No, it's
No.
a little bit bigger.
Oh, is it this thing?
Try
Oh,
the
that-
other side. So it's gonna be circular,
Okay.
and you're gonna see sort of a ring. And if I
Oh,
zoom,
is it this?
Yep.
Oh,
that's
okay, so it's
exactly
going off the edge of the grid.
it. Yeah.
Oh, wow, yeah, no, now that I know what I'm looking at, it is actually pretty distinct. Wow, look at that.
Is a beautiful Roan oocyte.
Okay, so that is a grade A oocyte ready for official pickup from this dish to go into your little vial over there.
Correct.
Okay, so how do you actually pick it up?
So we use, if you've ever been in a research lab or any other lab, it's called a pipette.
Yes.
So I'm gonna come here. You see how big that pipette is?
Oh, wow, yeah, that's crazy. Gobble. Wow, just like that. You got it.
And then she's gonna go in here. We're gonna keep looking. We're gonna see if we can find some more eggs.
Oh, is that one there?
So it is, but we're missing a key ingredient here. So
It looks empty.
it's empty. So sometimes that happens. I'll still move her over just to give her another look. It's not the best thing when it happens.
To have an empty oocyte.
Yeah, because it means we don't have an oocyte that we can clone with.
Okay, so Daria, what are we looking at now?
So now we've pulled all of those oocytes out of the first dish. And they're in a wash dish, and so you can see there's 1, 2, 3, 4, 5, plus our little one that doesn't have an oocyte actually in it.
So Parker's 6 for 6, you're 6 for 6. Matt is 1 for 1 with tranquilization. This is a heck of a process right now. So what we're looking at here on the screen is potential.
Yes.
And 5 of these 6 have the potential for what next?
So the ultimate goal is to make our bluebuck. And so the goal is to take these oocytes and hopefully clone a bluebuck with edited bluebuck cells.
Very cool. So we will need to take these out of the dish, put them into a transportable incubator?
Yep. And
Okay.
then we will fly back to Dallas and hand them off to our embryology team. And you're gonna get to see the actual next steps of cloning and how we actually make the bluebuck.
Okay, sweet.
I'm gonna put them onto a special plate and then hand them off to Nock.
Okay.
And then you can sit next to her and watch the whole process up close and personal.
What is this machine?
So this is a specialized microscope that allows us to do all of the cloning. But if you look at your screen, Nock's picked up one of our oocytes already. She's that fast.
Wow.
What you see here is a glass, what we call holding pipette. And so Nock uses that in order to suction back just a little bit so she gets a good grip on them. Then in our other pipette here, she's gonna turn the oocyte until she finds the nucleus. So think of the oocyte like your house. You've got all your furniture inside, you're now leaving. We wanna remove the contents of your house. That's what the nucleus is. It's what makes you, you. Essentially, she's burrowing her way a hole right through that zona pellucida.
Whoa.
Now she's gonna grab onto where that nucleus is, pull back. Perfect. Textbook definition of how you enucleate.
She got it, it's in there?
So she got it, it's in there. So now all your contents of your house are in that pipette and she's gonna discard it.
Wow. Okay, so that nucleus was like, we don't need that anymore.
Correct.
Get him out of here.
So that's the nucleus of a Roan. So these were Roan oocytes that we collected in Florida.
Yes.
But we wanna make a bluebuck. We don't wanna make another Roan. So Nock's gonna go down to a second area on her dish where she's got Roan turned bluebuck stem cells.
So these are genetically edited
Yes.
to make a bluebuck.
Yeah. Our amazing genome team has been working really hard to figure out what makes a bluebuck, what parts of the genome do we need to change from the Roan to make it into a bluebuck. They've created those cells and they pass those cells off to Nock. So she's gonna pull back one of those cells that is what's going to be the bluebuck.
Oh yeah, look at that.
She's now gonna find that oocyte. So she knocked down the old nucleus of what the Roan was. She's now going to regather her oocyte. She finds her hole again that she went through before, and now she's gonna inject the nucleus of our bluebuck.
There it is. And life finds a way.
And life finds a way.
Wow, okay, so now that the bluebuck nucleus has been transferred into the cell, what happens next?
So after Nock's finished, we now need to wait for a few days, actually 7 days, in order to become a blastocyst. In here, we've got several incubators going with different cultures. And so if you look in here, we've actually got a dish going with some embryos from last week.
Okay, so these embryos are almost ready to be then taken back out into the field?
Yep.
The process as a whole is very similar to what you guys did then with direwolves, where you've got a surrogate roan antelope that will then carry this embryo until it gestates and becomes a bluebuck.
Yeah, I think you have my job.
And similar to the thylacine, which of course is a marsupial, the bluebuck was also driven to extinction by humans, correct?
Yeah, it's the first described human extinction event of a large mammal in Africa. So it's a really significant loss of a really unique species. Again, one of these animals that there's nothing else that has that same role in that ecosystem. It was really very unique. And so to lose these animals is really tragic. But as a human-driven extinction, now we have the ability to undo some of those mistakes we've made in the past. Now we understand how important these species were, and we can do the work to actually recreate them and hopefully fix some of the problems that we've created.
I mean, all that grazing that they do becomes this amazing dispersal system, but they're also really considerate grazers, whereas, you know, domestic cattle tend to just level grasslands. Antelope, for whatever reason, they have a more natural grazing cycles where they'll pick and choose and they won't eat it down to bare earth. Their hooves turn the soil and we get all that great nutrient cycling that happens. They create little micro ecosystems for a lot of other animals that can live on the grasslands with them. So they become this amazing ecosystem engineer, seed disperser, and hopefully also an icon of de-extinction that helps drive conservation action.
I guess that brings us to the end of this episode and understanding that Colossal is officially bringing back the bluebuck, and it all has to do with the fact that conservation is the core behind everything Colossal is doing.
Absolutely. Everything has a conservation story and a message and helps more than just the species we're bringing back. It helps all of the species that are associated with it.
Okay, we are taking the Roan antelope back to its enclosure where we will administer essentially the reversal serum. And within a few minutes, this beautiful animal will be back up and running around with its corral mates. And is there any estimate as to when we might see our first specimen?
Well, you'll have to subscribe to Colossal's YouTube channel to stay up to date with all of the latest advancements across all of our projects.
Very cool. Well, thank you for all your time today in the lab and of course in the field. Guys, hopefully you really enjoyed this episode of how we went from getting hands-on with an animal to then understanding the science that Colossal is doing here to de-extinct species and most importantly, preserve species heading into the future. I'm Coyote Peterson. Be brave, stay wild. We'll see you on the next adventure. If you're fascinated by the bluebuck, make sure to check out Colossal's YouTube channel for the premiere of their new documentary, The Lost Blue Antelope of Africa, and learn more about why bringing this species back will help future-proof the endangered antelope that still roam the planet today.
So iridescence is the term for changing the way in which we perceive light. We think this is the case with the bluebuck. They also have these similar properties in their hair where there are these tiny little structures that help to bend the light in the way that really gives them a very blue-like appearance.